Chandrakala, working as Assistant Professor in the Department of Artificial Intelligence and Data Science from Tech Multitech Dr. Rangarajan Dr. Shakuntala Engineering College. Welcome to today's lecture on search algorithms in artificial intelligence. Why search algorithm is very important in artificial intelligence? Because search algorithm is a fundamental operations in artificial intelligence. Whether the GPS is finding a shortest path or Google retrieve the results or robot finding its way through a maze. Today we will see how the search algorithm help us to solve such kind of the problems. Search algorithm is very important in the artificial intelligence because it is the backbone of the problem solving in the artificial intelligence. So these algorithms that are mainly used to solve the given problems, and it provide the minimum solutions, minimum cost, and it is mainly based on the environment, that is adapt the environment and provide the solutions of the given problems. So that the search algorithms play an important role in the artificial intelligence. Let's discuss about understanding the role of search in the artificial intelligence. So search problems mainly involves the various navigations from the initial state to goal state through the various actions that make a better decisions to find a solutions. It has to be represented in the structured way of format that make a better decisions of the various tasks. The agent must explore the different path to find a solutions of the particular problems. These search problems mainly consist of the initial state, actions, goal state, and then path cast. So we have to discuss one by one. First of all, what is initial state? The agent has to begin, that is called as the initial state. Then actions. What do you mean by actions? What are the possible moves or decisions that make a better decisions or actions? That is called as the actions. Then goal state. Whatever it is, whatever the problem, I have to find a solutions. The better thing is you have to reach the target, reach the goal state. That is the desired outcome or target. Then pathcast. Pathcast has to be represented in the numerical value of the cast, so that effort required to reach the goal state. Next we discuss about the search algorithms. Use the search tree or search graph. So first of all, what is search tree? All the elements that has to be represented in the structure format, that has to be represented in the tree or graph. The branching structures that are generated from the initial state without revisiting the past state, that is called as the search tree. Then search graph means the efficient structures that accounts for the repeated states and the share the path. It may be used to reduce the redundancy. So the next one is what are the key terminologies in AI search algorithms? So these are the important key points of the search algorithms. That means efficiency elements of the search algorithms. First one is state space. What are the possible states? The agent can reach the goal state, that is called as state space. The next one is node. Each and every element in the search tree that has to be represented the node. So these include the metadata like the given metadata, it contains the large amount of data or information that like parent node, path cast, and depth. Then other element is frontier. So it is also known as the open list. So that are mainly used in the waiting in the queue of the node that has to be explored. That is called as the frontier. Then explored set. So what do you mean by explored set? The set of already visited node that are mainly used to avoid the redundancy. Then cast functions. The cast functions play an important role in the search algorithms. So first you have to find out the cast from the start node to node n. It has to be represented g of n. Then what is h of n? The heuristic estimate of the cast from node n to goal node. So finally had to estimate the total cost. It has to be represented in the f of n equal to g of n plus h of n. This is the estimated total cost. Next we discuss about the search algorithm properties that are very important in the search algorithms. Each and every algorithm must meet the properties. So first one is optimality, second one is completeness, then finite search space and non-negative step cost, then explicit goal definitions. First of all, what is optimality? That are guaranteed to provide the best solutions of the given problems, that is called as the optimality. Completeness, whether each and every node has to be visited and each and every node, that is called as complete, and also it to provide a solutions. Then finite search space, it is a limited search area. So the non-negative step cost is mainly used to prevent the negative path cost. Then finally explicit goal definitions, clearly that are mainly define the search target of the particular node. Now we discuss about the various types of search algorithm. The search algorithm that are mainly divided into two types. One is uninformed or blind. Another one is informed search algorithms. These uninformed or blind search also divided into six categories. First one is breadth first search, is shortly denoted as the BFS, and then DFS, depth first search. The another one is uniform cast search, then depth limited search, then depth iterative deepening depth first search, bi-directional search. Then informed search algorithms also divided into best first search and A-star search. This is about one type of searching algorithm, so uninformed search algorithms in artificial intelligence. Uninformed or another name is blind search, which means does not contain any information about to reach the goal node, that is called as the blind search. So uninformed searches do not have any domain knowledge. It works in the brute force manner. So it is called as the brute force algorithms. It does not know about how far the goal node is present and how to get around the difference between the leaf node and a goal node. So each and every node is examined without a prior knowledge. So that this algorithm is called as the blind search. So the uninformed search, that are blind search, does not know about any information to reach the goal node, that is called as the uninformed or blind search. About the one type of search algorithm, breadth first search. So in this case, each and every node explore the level by level. So all the nodes start from the root node, and it can be expanded to reach the all the neighboring node before we need to move to the next depth level. In this case, the breadth first search traversal from the root node S and S to A, and then A to B, then B to C, then C to D, D to G, afterwards G to H, and H to F. So the goal node is K is the goal node. Afterwards H to E, then E to F, F to I, and then I to K. So each and every node has to be traversal in this diagrams. Each and every node has to be visited. So the breadth first search started from the root node, and it has to be moved to the neighboring node, visit the all the neighboring node, and finally it reaches the goal node. BFS, whatever the searching algorithms that are mainly used to find the shortest path. So in this BFS algorithm, breadth first search is an unweighted graph that has to be represented in the tree diagram. It is complete because why it is complete? Each and every node has to be visited and it has to be reach the goal node, and optimal when all the actions have the equal cost. So it should be optimal one. Then it consumes a lot of memory because each and every node has to be visited, so it consumes a lot of memory. So especially for the large or deep search spaces. So it is the complex problems to solve the solutions of the particular problems. So what are the main properties of the search algorithms? Already we discussed in the previous slides. First one is completeness. What do you mean by completeness? It reach the goal node. So that is BFS is complete. And then it is find the solutions of the particular problems. Then optimality. Optimal means the minimum cost. So it has a minimum depth. Each and every node has the equal cost. Then time complexity and space complexity, it has to be represented in the order of B into D. So BFS may generate the 1 plus B square up to the order of B power D. So each and every node has to be represented in the time complexity order of B power D. Then space complexity order of B into D, because the Q is the frontier, the hand hold the each and every node at last level. So space complexity is denoted as the order of B into D. Next we discuss about the advantages of BFS. So it is provide the shortest path because it is an unweighted graph. So that is BFS guarantee to provide the shortest path, that is a minimum number of edges. It has to be start the node to the goal node. Then it provide the completeness because of the provide the solutions of the problems. The BFS is always find the always find the solutions of the given problems. So this also the advantages of the BFS. The another one advantages is systematic explorations, which means all the node at one depth before moving to the next node. So that is the good problem for finding the solutions, and it has to be reach the goal node. So then work for both trees and graphs. It can handle the cycles by using the visited set of the node. Then you have to good for finding the nearest solutions of the problems. So these are the advantages of breadth first search. Next we discuss about the disadvantages of BFS. What are the disadvantages? Already told about the lot of memory. It consumes a lot of memory because each and every node has to be visited. So it is disadvantages of high memory usages. Then it is slow for the deep solutions because each and every node far from the root node. So it wastes the time exploring all shallowest level first. And then it is not suitable for the infinite graph. Then it ignore the path cost because it works only for the unweighted graph. So it ignore the path cost, and then overhead of the queue operations because it is weighted for the queue where you have to reach the each and every node. So it can make BFS slow compared to the DFS. So in the low memory systems, these are the disadvantages of breadth first search. So second algorithm is depth first search. So to overcome this breadth first search algorithms, so we have to introduce the depth first search to overcome the disadvantages. So we introduce the depth first search algorithms. So it is explores as deep as possible along each branch before backtracking. So it is uses the stack structures, that is last in first out or regressons. It is making it a efficient one. So depth first search also explore each and every node in the levels. So start from the root node. Here is the goal node is represented as the G. The depth first search traversed from S to A to B, then B to D, then D to E, and then E to C, then C to G. So in this case, it reaches the goal node because it start from the S to goal node and then reaches. So the right side of the traversal does not reaches. So the depth first search consumes the low memory in this case. So to overcome this breadth first search, the depth first search algorithms provide the less memory, and also it is easily find the solutions of the given problems. Then it uses the what are the main key points of this DFS. So it uses the data structure stack last in first out, and then D first. Then backtracking is also its main advantages. It's not optimal because it not visited the all the node. So it is not optimal, but it provide a complete solutions because it reaches the goal node. Then complete na, yes, it is complete because only if the graph is finite and there are no infinite path of the node. So that it should be complete. That are the main key points of the DFS algorithm. So the next, what are the main properties of the search algorithms? Each and every algorithm has to meet the time complexity and space for complexity. Here B is represent the branching factors and M is a maximum depth of the search algorithms. So the time complexity already discussed in the previous one BFS algorithms. It has to be represented O of B into M. Here M is represent the maximum depth of the search tree. Then space complexity order of B into M, only it store the current path and the backtracking informations. So what are the main advantages of DFS is provide the better efficiency compared to the BFS. Next, we discuss what are the advantages of depth first search. The main advantages is low memory requirement because it only store the current path and unexplored the siblings. So the time complexity already represented in the O of B into M. Then it can work in the infinite spaces because the depth limit is set. So it can handle the very large or infinite search spaces. And another one advantages is good for complete explorations, which means each and every node explores the levels. So this is mainly used for connectivity checks. So this is the advantages. Then another one advantages of DFS is can be faster than compared to the BFS. Then easy to implement. These are the advantages of depth first search. So next one is disadvantages of DFS. It not provide the optimal solutions because each and every node has not be visited, so it not optimal, and it sometimes can stuck in the infinite path because without visited set or depth limit DFS may be loop forever. So because here it applied in the backtracking, so sometimes it can get stuck in the infinite path and maybe miss the shallow solutions. So near the start, the BFS will find it faster. Then sensitivity to path order. So the order of neighbors can greatly affect the search time of the given problems. So these are the disadvantages of the depth first search. So the next algorithm is iterative deepening depth first search. The iterative deepening is the combinations of efficiency of BFS and then DFS. So it can be run in the DFS repeatedly to increase the depth limit. So already know about the BFS and DFS, the each and every node explore the levels. So what are the main key points of the iterative deepening depth first searches? So it do the depth limited search. Already fix the limit of the level. Then it also uses the stack data structures, and it provide the optimal solutions for the unweighted graph because it is efficiency of BF. It is a combinations of BFS and DFS, and then it provide the complete solutions because each and every branching factor is finite. Then tree traversal. So in this case, each and every level of the node has to be fixed. So in this case, for the first iterations, it has to be visit the root node. It should be represented as A. The second iterations, the tree traversal from A to B or A to C. So it is the second iterations, that is the level 1. So after the third iterations, so A to B to D and then E to C and then F to G. This is that is the third iterations. We got the solutions. So no need to move on to the fourth iterations in this case, but we will find the goal node in the for the iterations. Again you have to find the solutions A to B to D, H, I and then C, F, K, G. So no, you got the solutions. You need to it does not need to move on to the fourth iterations because you got the solutions in the third iterations. So in the fourth iterations the algorithms will find the goal node. So each and every iterations, that means each here represented in the level. So each and every iterations has to be fixed. So the DFS and then BFS provide the efficiency of the IDDFS. That means iterative deepening depth first search. In this case, the level 2, you have to find the solutions of the given problems. That is the main advantages of iterative deepening. So each and every node has to be allocated in the iterations. So in this search tree algorithms, the level 2 you got solutions of the given problems because the goal node is represented in the level 2, but the iterations you got the solutions of the fourth iterations. Next we discuss about the time and the space complexity. So already know about the time complexity because combinations of BFS and DFS. So it provide the order of P to the power of D. Then space complexity has to be represented the order of B into D. The same as the depth first search. Then discuss about the what are the advantages. So it provide the optimal because it like a BFS for unweighted graph. Then and also provide the low memory usages because it's like a DFS. Why it should be provide the low memory because the efficiency of the algorithms BFS and DFS is combined together, so that iterative deepening depth first search provide also the low memory consumes. So and it works well when the depth of the goal is unknown, and it also avoid the infinite loop. These are the advantages of the iterative deepening depth first. Next we discuss disadvantages. So we have to repeat all the nodes. So multiple times you have to repeat at the all the nodes. So it consumes a lot of memories and also more work than BFS in the theory. So and to provide the solutions is very slow. So it's a very deep depth of the search tree algorithms. Next searching algorithm is uniform cost search algorithms. In this algorithms, each and every node has to be represented as the weight. So these algorithms expands the least cost node first using the priority queue. So it behaves like a breadth first search when compared to all the costs are equal. So that each and every node represented as a weighted graph. So in this tree diagram represents S is a root node and G is the goal node. So compared to S to A and then S to B, so here the weighted graph has lower minimum cost is 1. So the tree traverses from S to A, and then these are compared to A to C, whether it is A to C move on to other node or A to D. But in this case, A to D only the weighted graph represents 2, and then A to C represents 3. So move on to the A to D, and then D to G is here the D to G is your goal node. So here also represented the graph weighted as 3. So move on to the D to G. So G is a goal node. So tree traversal from S to G is S to A and then A to D and then D to G. So each and every node explores the each and every levels. So the next one is, so it always picks the least cost path from the start node. So here using the priority queue data structures, then and to provide the optimal solutions because it reaches the goal node, and it should be finite positive cost graph. So it should be a complete solutions of the particular problems. Then main properties of the algorithm is time complexity and then space complexity. So it should be large and it depends on the path cost. And the space complexity, it store all the frontier node and the priority queue. So the next one is advantages. It provide the optimal solutions for the positive edge casters, and it works for weighted graphs. So it like unlike the breadth first search, and it provide the complete solutions for the given problems. So these are the advantages of the uniform cast search. And then next one is disadvantages. It is slow algorithms, because each and every node has to be traversed in the small cast path exist before the goal node. So it should be traversed from the slow path of the node. Then it will provide the high memory usages, because all the node store all the path based on the priority queue, and it can expand the lot of unnecessary nodes. So the next one is algorithm. Next algorithm is bi-directional search. So by means two simultaneous searches. By means two. So each and every node runs in the two directions. One forward from the start node. Another one is backward from the goal node. So it has to be represented in the diagrams. So each and every node has to be separated, that is intersected. So one node is forward from the root node to goal node, and then another one is searches from the goal node to reach the next node, goal node to traverse, that is backtracking algorithm used in this bidirectional search. So in this bidirectional search, each and every node has to be separated, that is intersected node. So one from the forward, another one from backward search. So next properties of the bidirectional search algorithm is provide the time complexity and then space complexity. So it faster compared than the BFS because it should be large one. So but the smaller than the BFS provide the space complexity. The space complexity is very slow, very lower. Then advantages of the bidirectional search is much faster than the breadth first search, because each and every node has to be searched in the bidirections. So and also it provide the solutions, optimal solutions for the unweighted graph. So another one advantages is useful for the problems finding the where the both start and the goal node are known. So next disadvantages, it require the backward search problem. So all the node it's not possible to reach the goal node. So it need the more complex because the implementations is compare than the BFS. So it should be more complex. So bidirectional, this is two searches. So more memory required than compared to the BFS. DFS, depth first search. So these are the disadvantages of the uniform cast search. So in this slide, we will explain about the SDG Sustainable Development Goals. Totally 17 SDG goals are there. So first one is no poverty, zero hunger, and then good health and well-being. Fourth one is quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry innovations and infrastructures, reduced inequality, sustainable cities and communities, responsible consumptions and productions, climate action, life below water, life on land, peace and justice, partnership for the goal. These SDG goals, how it is related to search algorithms in artificial intelligence. We discussed the SDG goals related to the artificial intelligence search algorithms. In this search algorithms are related to the SDG 3 because it is a good health and well-being. This search algorithms that can be used in the health medical diagnosis systems, that is to find the optimal treatment path or drug discovery. For example, A-star search algorithm, that is the informed search algorithm that are mainly used to help in finding the shortest path for emergency responses in the hospitals. So the next SDG goal are also mapped with the search algorithms, SDG 4. that is provide the quality educations, the AI search algorithm that are help in adaptive learning platforms that are mainly recommended to best learning path for each and every students. So the next SDG goal, SDG 7, affordable and clean energy. These such algorithm techniques that are mainly used to optimize the energy grids and smart city power distributions. So uniform cost search algorithms can also minimize the energy loss in the transmissions. Next SDG goals are mapped with the search algorithm is SDG 9. So industry innovations and infrastructures, these algorithms are the backbone of the robotics and automations. Next SDG 11, sustainable cities and communities. So main thing is pathfinding algorithms. These algorithms A star and G star algorithms that are applied in the traffic management, public transport planning and waste collections optimizations. The next SDG 12 is mapped with the search algorithms, that is responsible consumptions and productions. The search algorithms can optimize the resources allocations, and then manufacturing processes that are mainly used to reduce the waste. Then next SDG goals are mapped with the AI search algorithms in AI. So SDG 13, that is the climate actions. So AI search supports the climate model and predict the disaster responsibilities and then route and optimize the renewable energy uses. Thank you for watching. I hope you found this lectures on search algorithm in artificial intelligence is very helpful to you. Thank you all.